Hello knowledge seekers, welcome to Remedial Tutorial Academy. In this video, I'm going to cover what rational numbers are. Now simply put, rational numbers are numbers that can be written as a fraction. Specifically, a fraction of two integers. So the numerator must be an integer and the denominator must be an integer. Now fractions can be written as decimals. So anything in decimal form that either terminates, so cuts off, or repeats, so continues on forever in some type of pattern, those are rational numbers. This may all seem confusing at first, but as we go through our examples, this will all make a lot more sense. So any number that can be written as a fraction of two integers, so the numerator must be an integer and the denominator must be an integer, that's going to be a rational number. Now remember, integers include positive and negative numbers and zero. Decimals and fractions are not included. Now, one thing I do want to mention, the denominator cannot be zero because that will give us a value that is undefined. That's why zero is crossed off for the denominator. So something to keep in mind. Let's jump into our examples, starting with number 1 where we have 6. So we have a whole number here. Can we write 6 as a fraction of two integers? Yes, for example, we can write 6 over 1. That equals 6. Or 12 over 2, that equals 6. 36 over 6, that equals 6. All of those examples equal 6. So 6 can be written as a fraction of two integers. So it's a rational number. And all whole numbers are going to be rational. What about negative 6? What about a negative number? Can we write this as a fraction of two integers? Yes. Negative 6 over 1 equals negative 6, or negative 8 over 3 equals negative 6. So negative 6 is a rational number as well. Let's move on to number 2 where we have a decimal, 7/10. Is this rational? Well, it is a terminating decimal. It cuts off. So right away we can see that this is rational. But can it be written as a fraction of two integers? Yes. 7/10 can be written as 7 over 10. That equals 7/10. Or 21 over 30 equals 7/10. Or even 70 over 100 equals 7/10. So 7/10 can be written as a fraction of two integers. So it's rational. And just like we talked about number 1, a negative, so negative 7/10, that's rational as well. We can write this as negative 7 over 10. So any terminating decimals are going to be rational. Let's move on to number 3, where we have 2 and 75/100. Similar to number 2, we have a terminating decimal. So right away we can tell that this is rational. But how do we write this as a fraction of two integers? Well, we can write this as 275 over 100. Or we can even use the simplified version of that fraction, 11 over 4. So both of those are examples of 2 and 75/100 written as a fraction of two integers. Now, just like numbers 1 and 2, negative 2 and 75/100 is rational as well. We can write this as negative 110 over 50. Can we write that as a fraction of two integers? Let's move on to number 4, where we have 0. Is 0 rational? Yes, we can write 0 as a fraction of two integers. 0 over 1 equals 0. 0 over 25 equals 0. 0 over 100 equals 0. So yes, we can write 0 as a fraction of two integers. 0 is rational. Now, like I mentioned earlier in the video, if we have 0 in the denominator though, so let's just say 1 over 0. This does not equal 0. 0 in the denominator gives us a value that is undefined, so that's not going to be rational. So again, something to keep in mind. Let's move on to number 5, where we have a repeating decimal. So 0.3 repeating. This bar right here, this means we have 0.3, and this 3 continues on forever. So is this rational? Are repeating decimals rational? Can we write this as a fraction of two integers? Yes, we can actually write any repeating decimal as a fraction of two integers. For example, a fraction of two integers that equals 0.3 repeating, well, 1/3, or 3/9. So any repeating decimals are rational. Even something that has multiple digits that repeat will be rational. So for example, something like 0.181818, and this continues on, so 18 repeating. We have a pattern here. We have something that repeats. So this is rational. Fractional form, let's come below here. So 0.18 repeating, we can do 18 over 99, or even 2 over 11. Next, for number 6, we have 1/4. Well, this is already a fraction. The numerator is 1, which is an integer, and the denominator is 4, which is an integer. So this is rational. Now, let's look at the decimal form as well. 1/4 equals 25 hundredths, which is a terminating decimal. So we can see that this is a rational number that way as well. Let's move on to number 7, where we have the square root of 25. Well, the square root of 25, that equals 5. So with the square root of 25 giving us the value of 5, is 5 rational? Yes, 5 is a whole number, and we can write it as a fraction of two integers, 5 over 1, 50 over 10, so on and so forth. So the square root of 25 is rational. Lastly, let's move on to number 8. And at this point, you may be thinking, well, what's an example of something that's not rational? Well, the square root of 3 gives us a value that is not rational. If we plug this into a calculator, we get 1.73205, and this continues on forever. Now, this decimal does not repeat, it doesn't have a pattern, and again, it continues on forever. So the decimal form doesn't terminate or repeat, so there is no way for us to write this as a fraction of two integers. So this is not rational. Again, there's no way for us to write this as a fraction of two integers, but you may be thinking, can't we just write this as the square root of 3 over 1? That's a fraction. Yes, it is a fraction. But remember, a rational number is any number that can be written as a fraction of two integers. And this numerator is not an integer. Again, this numerator and denominator have to be an integer for it to be rational. The square root of 3 is not rational. It's what we call irrational. We cannot write it as a fraction of two integers. And going off of this, anytime we take the square root of something that is not a perfect square, or a cube root of something that is not a perfect cube, and so on, we get an irrational number. And there are other examples of irrational numbers as well. We will go over those in another video. That link is down in the description. So as far as rational numbers go, if we can write it as a fraction of two integers, then that number is rational. If the decimal form either terminates or repeats, that also shows that we have a rational number. So there you have it. There's an explanation of what rational numbers are. I hope that helped. Thanks so much for watching. Until next time, peace.